Hi, everybody. Welcome to the AWS Technical Workshop Series Virtual Work Placement Program. This is workshop number 2, AWS Cloud Foundations, where you're going to be building your first API. Welcome. I'm really excited to be talking to you today. My name is Jacob Cantwell. I'm a solution architect at AWS. Today, along with myself, Emma, who presented yesterday about bots, and Joseph, who will be presenting tomorrow about artificial intelligence and machine learning, we'll be supporting you. Any questions that you have about the workshops, presentations, please go into the Slack channels, and we're here to help you. I want to give you a bit of background about myself. So uh, I did my high school, I finished my high school in California. Uh, I actually started university there and then transferred to UNSW and did a degree in chemistry. And after that, a Master of Commerce at Sydney Uni in economics. In all that study, I was always very interested in computers and programming and always sort of building applications and software. So I've got a long background of building applications that run in your web browsers, say, um, imagine like your banking applications or and building applications that run on your mobile phone, so like your iOS or your Android apps. And recently, I've been building applications that run on constrained Internet of Things devices. So these are really small computers that can fit into a light bulb, and you can control them remotely. So I I'm a big fan. I'm a big builder. I love building apps for fun. I've been doing a lot of fun activities with our AWS Deep Racer program recently, which is a way where you can learn about reinforcement learning, and that's used to, say, teach cars to autonomously drive around by themselves, which is really fun. And I've attached here's my LinkedIn um, link if you want to reach out and connect, talk about anything about AWS. So what are we doing this week? Again, um, these sessions are all about you getting hands-on building on AWS. So we started yesterday, Emma, building your bots. Now, today's session is how can you integrate that bot into other AWS services? So that's normally when you're uh, integrating things like services talking to each other. Those are normally done through APIs. So and then tomorrow, Joseph is going to talk to you about object AI and machine learning and doing some neat object recognition and combining, say, APIs and bots and AI and ML. We really hope you can start thinking about what are some really neat real world problems that you might be able um, to develop yourself. So the technical workshop agenda is on this link, which we'll share in the chat. So that is the same for Tuesday, Wednesday, Thursday this week. And you'll just move on to the Work to workshop on that website. So we'll also have later today office hours in this, so you can join in and talk to your mentor, any questions that you have. We've got the Slack running all through the week. And let's get started. So what I want to talk to you about today is we're going to jump into some really computing basics. So, you know, what are computers and servers? and then expand on that into what is the cloud. So it's sort of we're, what we were traditionally doing with computers, and now what is the sort of this new way of deploying computers with the cloud. I'm going to talk to you about some of the foundational AWS services. So these are the services that our customers use, or a lot of our customers use all the time. How you can get started. There's a spelling mistake there. Learning and leaning on AWS, and we'll have uh, some more details on the workshop at the end. So my job as an AWS solution architect is really helping my customers get really hands-on and helping them build on AWS. And I've been working in the IT industry for about 20 years now, and I have to say that working as an AWS SA is by far the most fun job I've ever had. You're you're having a huge range of conversations on all different topics on how to build an app, what are the security best practices, how can I cost optimize the solution so you can save money. I present with other customers at if something they've built. I always try to promote the work that they've done. There's always a big variety of different projects we're working on, so it's all really interesting. You get to talk to a lot of people, learn about what they're building, and that's just really fun for me. I really like it. Um, so, and I always recommend, have a look on our AWS jobs website. There's literally hundreds of jobs. We're looking for people. The cloud is growing at an amazing pace. Um, so part of my job is I interview candidates that are applying. So have a look at those Amazon leadership principles. That's really important. Uh, so yeah, let's talk about computing basics. So what is a data center? Here's a picture of a data center. So these are the data centers are basically well these buildings that are storing hundreds or thousands of computers and servers. So a server is basically just the all has all the same things that are in the computer that we're using right now. So it has the CPU and the memory, an operating system, and the servers are just in sort of a smaller form factor so that they can easily stack lots of them on top of each other into these rooms. So here's a picture of a server rack and the rack space with a bunch of different servers in it of all different types. And here's you can see inside there's part of the networking equipment. So there might be a security cage. So you got to think, if this rack is maybe in someone's office, you want to have a little lock on it. There's all different types of servers that might be running doing different things. Um, they might be used for saving files. They might be using for networking control. So this is really sort of what those racks look like in the data center. And you have to think about in traditional data center, say you've got a project, how many servers do I need for that project, right? You have to sort of make a guess or based on how popular you think this your application is going to be. So you think, oh wow, this is going to be really popular, and then maybe I've got to go and buy hundreds of different servers and then come and get them installed and put them into these racks. And each of those servers, those are physical devices. They need power, they need cooling, they need to be in clean, relatively dust-free rooms. They're running software that needs to be maintained. So there's a bit of effort in running these servers and data centers. And what normally happens is when you're deploying your applications traditionally, you would choose a primary data center. So that would be somewhere close to where your customers are. And you might have a backup data center. So say if there was a problem with that primary data center, you'd have a backup of your data somewhere else, so that you can sort of recover if there was a problem. And again, what are some of the problems with this traditional data center approach is it can take half months, 6 months to order new equipment. You're really guessing how much server capacity you're going to need, and say what happens if your application does become popular. Uh, if and then like a million people want to come and use that your application, um, then you have to go and get more servers and wait more months to go and buy these servers and put them in your data center. So there's a lot of shortcomings if with the traditional way of buying, maintaining your own servers. So what that leads us into this sort of new way of thinking about how do you provision your IT resources and your computing servers. And gets us to ask what is the cloud then? So the cloud is this is our definition of the cloud. It's on-demand delivery of IT resources through the internet with pay-as-you-go pricing. So that on-demand part, that means, a few clicks through the AWS Management Console, you can spin up a new computer, a new server. Um, Through the internet, everything is connected through our networking through the internet. And the pay-as-you-go pricing means that you just when you need it, you spin up a server, then you're paying for the time that server's running, and then say you don't need it anymore, then you turn it off, you stop paying for it. So it's pretty simple. One way to think about it, analogy is, you turn your tap on for water, or your light switch for electricity. The cloud is that same concept for IT resources. And if you look at that traditional data center, Um, so you might have a primary or backup one somewhere. Now with AWS, you can deploy your applications in any one of these 26 regions, and then within minutes deploy it to any of the other regions across the world. So you're not taking months to buy servers anymore. It's that on-demand delivery of resources globally. So a few clicks, you can spin up a new service in Singapore, or a version of your application in Singapore, or maybe in the US, just wherever your customers are that are using your application. You can deliver your application closer to where they are, so they have a better experience. So AWS has 26 regions right now, and we're always announcing more regions. And a really exciting one for us in Australia is the Melbourne region, which will be opening in the second half of 2022. So we'll have two large AWS regions in Australia. So what are the benefits of moving to the cloud? So I talked about some of the pitfalls of traditional data centers, but that moving to the cloud really gives you some great advantages for your company. And agility is one of the biggest ones. So what we find is that companies that move to the cloud, they really increase their pace of innovation. And that means that they're able to launch products faster, create new features, and improve their customer experiences much more quickly than if they were just deploying servers in traditional data centers. So this is one of the largest benefits of moving to the cloud is the business agility. And I'll give you an example. Is Unilever is a large consumer giant, and they basically reduced the time to launch new products by 75%. So they had a massive increase in agility. And another great feature is that elasticity. So as that traditional way, you'd buy your servers up front, and then if your application becomes popular, oh, I've got to go to the store and buy a whole bunch of new servers and wait 6 months for someone to install it. Now that's a thing of the past now. So what happens now is you build your application, maybe it's only on one or two servers, but then it becomes popular. So for example, the I work with a few telecommunication companies, and there's things like the iPhone launches. So just for a couple days of the year, their amount of traffic going to their website increases by 100-fold, and they don't want to go and buy servers that can handle that traffic just for a couple of days events, and then the rest of the year it's not being used. But if they're using on the AWS cloud, then they can just have their servers running normally, and then say there's a big event comes up, they can spin up new servers, and then the event ends, turn it back down. So they get the benefit of that elasticity going up, so they can get more people using their website, and then turn it down when and not pay for it anymore um, after the event's finished. And there's a lot of benefits in around cost savings on moving to the cloud. So you have to think about the total cost savings. So when you get your own data center, you're buying the servers, you have to also employ people to maintain those servers. You need to employ people to update those servers. There's a lot of associated costs with all of the networking and infrastructure around running those data centers. Um, and we've got lots of case studies on companies that have, say, GE Oil and Gas, for example. They moved to the cloud and had a 52% reduction in their cost for running their applications by moving to AWS. And another thing to think about is all the time that your staff spend on configuring those servers. Um, that can there can be a lot of effort involved in that. So there's another example of Sage Software is one of our customers, and they save more than 500 hours per year just in server configuration time. So a lot of cost savings in capital outlay, but also in staff productivity time. And that other great benefit is being able to go globally in minutes. So that mean what with those 26 regions across the world, it means that your content in your application is closer to where your users are. So within a few clicks, you can have great customer experiences all across the world. So let's talk a little bit about AWS. So AWS has more services, more features within those services than any other cloud provider by a large amount. So we're continually expanding our services to support virtually any cloud workload. So that means any compute that you need, any storage or databases, any networking requirements, any of those robotics, machine learning, AI, Internet of Things, you're building mobile apps, any security or virtual reality, augmented reality applications, um, there's services for everything. So we've got the greatest breadth of services, but also really deep um, functionality in those services. So, for example, if I say we've got a compute service, we have over 500 types of compute instances that we can give our customers so they can optimize their workloads for the best price performance for whatever they're running. And for databases, there's over 15 different databases options. So we're always innovating faster than anybody. We released 3,084 new services or features in those services in 2021, and that pace of innovation is just constantly growing every year. And I'll give you an example. So Disney is one of our customers, and they're using AI and ML to process their all of their video content. So imagine some of their writers or animators, they want to look up scenes about which character appeared in which film. So they can do a search through their content and actually see the clips of which character is appearing where through their whole archive uh, catalog. And another really popular game is Fortnite. This is an amazing game. Not only in that it's really fun, but it has 350 million players on it now. Um, and there's through and in the season ends, you get hundreds of millions simultaneous users playing the game. The Epic Games is running on Fortnite is nearly all running on AWS. And one of the best advantages that Epic has said for running on AWS is they were really it was all came back to that agility, like that benefit of agility. And for Fortnite, that agility meant that they're able to really improve their development iteration time so they can really rapidly release new features and new content to players. And we've got AWS has the largest, most dynamic community. So we've got millions of active customers every month, more than 100,000 AWS partners from over 150 countries. So there's customers running across virtually every industry, of every size. There's startups, enterprises, public sector organizations. They're running every imaginable use case on AWS. And the great thing about that ecosystem is that every AWS customer has opportunity to benefit from the collaboration and feedback from every other customer. So 90% of what we build at AWS is all based on what these customers tell us what matters to them. And we also have a culture of builders. So we always are looking for builders that are always looking to improve the customer experience. So now I want to talk to you a little bit about our global infrastructure. So we have 26 regions. So our AWS services are hosted in our data center, our data center footprint, so that allows customers to consume the services without having to build or manage their own facilities or their own equipment. And those data center footprint is uh, divided into these clusters, which we call a region. So a region is this physical location around the world where we cluster data centers. For we've got 26 right now. We're growing really quickly. We've already announced plans for 8 more regions in Australia and Canada, India, Israel, New Zealand, Spain, Switzerland, and the UAE. Again, we've got the second region in Melbourne. And then over time, the goal is to put all of these regions into, we'll develop, we'll put regions where there's large developed geographies. So where our customers are so that they can get the best user experiences. And a region is, I'll talk about now what are the design behind a region. So a region is comprised of multiple availability zones. And the point of a region is to give you high availability, high scalability, and high fault tolerance. So that high availability means there's always going to be servers available. The high scalability means that, say, you need more scale, you need more compute or database or storage because you have a big event coming up, or and your application needs to scale, then you have that high scalability. And the high fault tolerance is, say there was a problem somewhere in one of the data centers that the system is designed to recover if there's any issues. So each region consists of multiple isolated and physically separated availability zones within a geographic region. So, and every AWS region contains 2 or more availability zones, and some regions have as many as 6 availability zones. So what is an availability zone? So an availability zone consists of one or more discrete data centers. So each has its own redundant power, networking, connectivity housed in a separate facility. So at a full scale, an availability zone could have hundreds or thousands of servers. So today we have 84 availability zones within those 26 geographic regions. And we've already announced plans for another 24 availability zones. And these data centers inside an AZ, they are connected via these redundant, ultra low latency networks, so they can replicate the data among themselves in real time. And the AZs, they exist on isolated fault lines, isolated floodplains, networks, and electrical grids. So, and that will help substantially reduce the chance of any simultaneous failure. That way, customers can focus on if they have high availability in their applications, by running them over multiple AZs, they can really achieve really great fault tolerance so that the applications are always available to customers and protect from any failure at any single location. And another really important commitment that Amazon has, and something our AWS SAs are really passionate about, is our commitment to a sustained future. So in 2020, Amazon became the world's largest corporate producer of renewable energy. We have a target to power 100% of Amazon through renewable energy by 2030, and we're on the path to reach that by 2025. And in 2019, we also co-founded the Climate Pledge, which is a commitment to have net zero carbons across our business by 2040. So that's, and one of the great things about the cloud is, well, compared to traditional data centers, is that this is coming from an independent research white paper, is that if you move your compute from your applications from on-premise workloads to AWS, you can reduce your carbon footprint by, it was 88% for the average average data center, and then even reduce it by 72% for those top 10 most efficient data centers. So this commitment to sustainability is now part of our core Amazon leadership principles. So those are the tenets that we do, how we do our business, and what we need to demonstrate in our actions every day. So let's talk a little bit about the AWS Foundation services. So what is really important to understand with AWS is that security and compliance is a shared responsibility between AWS and the customer. So this shared model can help relieve the customer's burden as AWS focuses on how we operate and manage and control the components and the operating systems, um, all the networking, that physical security of the facilities in which applications operate. So AWS is responsible for the security of the cloud itself. But then the customers, they assume the responsibility of what goes in the cloud. So those applications that they're building in the cloud, they assume responsibility of that. And that includes things like if they're spinning up a server, for example, patching that operating system, making sure that it's up to date, and making sure that they're following um, configuration of the say firewalls and networking. And we provide a lot of tools and that's part of my job as an AWS SA is we give a lot of advice on the best practices on running applications in the cloud, making sure customers are following the best security practices. And we divide our foundational services into three different areas. So compute, storage, and databases. So I'll talk about those now. So these are our core foundational compute resources. So with compute, think about you're spinning up a server. That could be a Windows server or a Linux server. These are what you're running your applications on. So at one end of the spectrum is your Amazon EC2 instances. So those are exactly those services that you saw in the data center. You need a new Windows server, a few clicks. You can spin that up on AWS and remote desktop into it and start doing whatever work you need to do on that EC2 instance. But once you're in the cloud, you can really start thinking about modernizing your applications. And that's where our container management services come in. So with the container management services, you're actually just building your application, you're bundling them up into these little packages called a container, and they will include uh, the libraries and other dependencies that the application needs to run. So with containers, you're just worried about your application. Instead of, say, in EC2, you need to worry about your operating system and your application. So the container services takes away a little bit, automate some of that underlying operating system management for you. And then to the very end of this spectrum is Lambda, AWS Lambda, which is one of my favorite services and also what we'll demonstrate today. And in Lambda, you're basically just writing code. So you write some code, click deploy, and that's it. So you don't worry about any anything except your code. And one of the great features of Lambda is that when you're only care about the code, you're not caring about maintaining operating systems or how your code's going to scale up and down. You can focus on agility um, and just building features. So that was something that Coca-Cola did really quickly with these new pre-styled drink dispensers, um, and a smartphone app that could integrate with these, so they could people can pay for drinks with a smartphone app. They don't need to touch anything. That was one of the COVID changes that came about, and using AWS Lambda behind the scenes, where they just had to um, write the function code. And this is a little bit so AWS Lambda, where you're just writing about the function code, you're not worrying about the underlying operating system. We call that a serverless service. So that means, again, you're not provisioning any operating systems, so there's nothing to manage. So very, very secure in that way. There's much less maintenance. When it comes to scaling, they automatically scale. So, for example, Pizza Hut was one of my customers last year. Really, if you imagine how often when people buy pizzas, so during the week, um, people not buying many pizzas, but then comes Friday, Saturday night, it ramps up to thousands of people ordering pizzas in minutes. So you write your code in the serverless services, and just automatically scales up to handle all these extra users that are coming in. But you're only paying for the value. So then after they leave, that traffic goes away. Those services automatically spin down by themselves, and you're not paying for it anymore. So you're only paying for when people are actually using your service. And they're also these, we call them serverless. They're always highly available, highly secure by design. And this is an example of Nielsen marketing. So they are using Lambda to process 250 billion events per day, using Lambda. So they're getting great cost savings. They're processing literally billions of events. Um, so it scales really well, and also it's secure and cost performant. And another neat feature that you can start thinking about um, with services like Lambda is sort of an event-driven architectures. So Amazon S3 is our durable storage service, which I'll talk about soon. But basically, it's a bucket where you can say upload files. So one event-driven flow that you can see here is, say, imagine you're taking a photo, you upload that to an S3 bucket, and then a Lambda can automatically process that image. So maybe resize it to different variations for different browsers and mobile apps. And you can do that with in a way that can scale, and it's pretty simple to develop. So let's talk a little bit about the next category of the foundational services, which is storage. So Amazon S3, Amazon EBS, Amazon EFS, these are the three different storage types that can be applicable for those different types of workload needs. So Amazon S3 stands for Simple Storage Service. So this is an object storage service. S3 makes data available through an internet API that can be accessed anywhere. An object is something like that photo text file where you upload it to your Amazon S3 bucket, but you can't It's not you can't edit it. It's just you can replace it with, say, a new version. But S3 is all designed for durability, so it's a really durable way to store data, and it's designed for 11 nines of data durability. So that means that statistically, if you stored, say, 100,000 files on Amazon S3, the platform's designed to lose only one object every million years. So S3 will replicate copies of your files across all of the availability zones in a region. So it's a really durable way to keep data. You want to make sure that it's safe. Then EBS, for example, so EBS is the next service. These are the volumes attached to those EC2 instances that I talked about before. So if you spun up an EC2, say Windows server, you need to add fast storage for that EC2 server. You would attach an EBS volume to it. So that's a really high performance storage with really low latency for an EC2 instance to talk to. And then finally is Elastic File Service is that is a way where you can share storage across your EC2 instance, those container services, or AWS Lambda. So EFS is designed for sharing files across different compute. And finally, I want to quickly talk about databases on AWS. So we offer 15 different types of databases. This is growing all the time. Traditionally, when you're building applications, you would use a relational database. You might have heard of MySQL. Um, there's quite a few different types of relational databases, and those are all based around creating relationships between different tables. There's a new type of database called NoSQL, a bit newer type of database. It's called a NoSQL database. We offer DynamoDB, which we'll show you today. And then Redshift is a way that you can, for companies that have massive data storage needs for the applications. So that's many terabytes or petabytes of data, and they want to be able to process that data and run reports on the data. But the point of having the variety and that depth of database knowledge of services is that customers have all different types of databases, and we offer this breadth of database service so that they can easily move or copy the data from the type of database that they're running now to the cloud. So really to make that migration a lot easier. And one thing that's really important to know is that all of our services, from compute, storage, databases, all of those 200 services are all linked together through or control. The access to those services is controlled through our IAM service. So IAM stands for Identity and Access Management. So this is used for tracking the users and identities, all the access in the system. So this is all managed through IAM. So when you want to give users access to AWS Management Console, or through any of our SDKs or your applications, you would manage this through IAM. And each of those users, they need roles and permissions. So the roles and permissions say who is allowed to talk to what. So today you're going to write some Lambda code that's going to talk to a DynamoDB table, and you'll see that that Lambda code will only be allowed to talk to a DynamoDB table if you apply an IAM policy um, in the role that IAM resource has that the Lambda has that says, hey, I'm allowed to talk to DynamoDB. So that applies to everything talking, every resource talking to every other resource. It has to have security permission to be able to talk to it. And we deal with a lot of enterprise customers as well that where we automate a lot of this security with their enterprise system so that you can have simple logins and just to make it all of that access a bit easier to manage. And one of the principles that as a solution architect you need to think about is basically you have to have this. It's called a zero trust model, and you use the principle of least privilege. And that means that every resource, every agent should only have the very minimal permissions necessary to accomplish its function. So what it's trying to do. So you always need to think about security. What's the best practice? How do you really minimize what each thing is allowed to do so you can make sure your applications are really secure as possible? So how do you get started? So one way that I got started on AWS, and something I really recommend is really have a look at our AWS certification programs. You start out with the cloud practitioner, um, then you go on to our associate um, level certifications, and then into the professional level certifications. But and I'll tell you, I have conversations with my customers every single week, and every SA that I work with has conversations with their customers every week, saying there's a massive skill shortage in IT, in the cloud technology. So our customers that we work with, they need more skilled students like yourself to come and learn about AWS and get really these great top paying jobs that honestly they're fun. You get to do a lot of interesting work. So there's a ton of companies. AWS needs you. All the partners that we work with need you. All their customers need you as well. Um, so yeah, I'll really have a look at this when you start thinking about um, getting started. And let me just go to the next stuff. So you've been playing with AWS Educate. That's a great tool. We use that a lot. There's a lot of other resources on like the SageMaker site if you want to learn a bit about machine learning as well. But the biggest thing is get really hands-on. So start building, like start get into that AWS management console. There's a free tier you can start playing with. There's AWS Educate, all of the labs inside of that where you can start getting in there, start building, start learning, start thinking about what customer problems that you could solve. So that's it for my presentation. What we're going to do now is what I'm hoping you can do now is jump into a workshop for day 2. And in day 2, you're going to be building your first, it's called a CRUD API in 45 minutes or less. So CRUD means create, update, and delete. So in this case, we're going to be creating an entry in a database. So creating a new entry, updating the entry, deleting the entry. Uh, and an API is a way for applications how they talk to each other. So if you have got your mobile app, your web application, you click on a button, that button is calling an API that's called an application programming interface to go and do something. And that's something that we'll see in the workshop today. that could be whatever logic you want to program. In our case, it's going to be writing to a database, but then you could start thinking about, what are these, what's my idea? What do you want to build? What are some customer problems that you could work backwards from? This is an example through Realtor.com that's quite similar to what we're going to be building. So you have mobile apps, websites, they connect through the internet. Those apps always hit an API gateway. So the API gateway controls access to who's allowed to call what. So if you need the user to be logged in to access to do something in the application, that's normally controlled through the API gateway. And then the API gateway would connect to an underlying resource. So that could be that compute resource, it could be a Lambda function, it could be that Amazon S3 bucket to uh, download a file or a database, for example. And this is the architecture of what you're going to build today in the workshop. So that is your client is going to be calling an API. So the HTTP means it's a protocol that's supported by your web browser. That API is going to call a Lambda function. So that API will need to have an IAM permission to call the Lambda function. And then the Lambda function is going to use one of our AWS SDKs, so just a programming library to be able to read and write from DynamoDB. And again, between that Lambda function, we'll need a IAM permission to be able to talk to DynamoDB. So just some tips, just because we are sharing our AWS accounts, just remember to put your name on the end of every resource that you create. So example, I've got a .jacob for my one, and then in any of the code, so say you're creating a DynamoDB table, if you change the name with say a .jacob at the end, your AWS Lambda code, you'll need to just look in the code for the references for the name and then update that. And then remember IAM permissions. Everything needs permission to talk to anything else. So security is job zero. It's the most important thing to think about. And that's it. So thank you very much. It was I've been really excited to work on these workshops for this week. If you have any questions, please go to the Slack channel, ask your questions, and we'll jump on. We're really excited to look, and we're looking forward to helping you out. Okay, take care, everybody.